All right, welcome back. So this will probably be about a half an hour or so tonight. We're going to get started. So this will be the first of numerous lessons on this topic. It's called parametric equations. So typically this doesn't go too bad. Parametric equations are pretty straightforward. There's a few formulas you got to memorize, but all in all, I would say this isn't not too bad. So a parametric equation, we'll start with having you guys copy a definition down. A parametric equation is when X and Y are split into two separate equations, and they're both going to be dependent or with respect to a third variable, and that's T. So these parametric equations are all going to be kind of split into X of T and Y of T. Parametrics are when you take two different things and split them both into respect to T or time, depending on what you're talking about. So we're going to do a whole variety of things with this topic. We'll cover, like I said, about half an hour or so worth tonight. The first thing we'll do is we're going to sketch. We're going to sketch the parametric curve and include orientation. All right, so to do that, whenever you don't know what something looks like, we should make a table. So now we've got these two equations. So what we're going to be doing is our table is going to have X and Y, and it's also going to have T, because these are both with respect to T. Okay, so according to this, we are going to graph this over the interval -2 to 3. So I'm going to start by mapping that out. -2, -1, 0, 1, 2, 3. Okay, and all we're going to do is we're going to plug this value into both equations. So I'm going to plug in -2 into the X equation. And when we do that, it's going to give us 0. And it's up to you guys how you want to handle this. If you want to plug all of these in for X and then all of these in for Y, or if you want to go -2 into both and so on, whichever way makes the most sense to you. But we're going to plug these values in for all of these. So I'm just going to go straight down the line and plug these into X. If I plug -1 into X, that's going to become -3. If I plug 0 in, that's going to give us -4. If I plug 1 in, that's going to give us -3. 2 is going to give us 0, and 3 will give us a result of 5. And then we got to do the same deal down here, but now we're going to plug these T values into the Y equation. So if I plug -2 in, -2 over 2, that's going to give us a result of -1. If I plug -1 in, that's going to give us a result of -0.5. If we plug 0 in, you're going to get 0. If we put 1 in, we're going to get 0.5. If we put 2 in, that's going to be 1, and 3 would give us 3/2. Okay, so now with these, we would make a table. And you got to start here at the beginning, and we're going to be plotting now these new coordinates that we came up with. So if I plot 0, -1, easy enough, that would be right there. And now we got to follow the direction. It said up here, include orientation. And orientation is going to be the direction that your points unfolded as we went through this. So the next one is going to be at -3, comma, -0.5. So I mean, just kind of eyeball it, -3, -0.5. That's going to be between obviously 0 and -1. And then we're going to keep going. This would be -4, comma, 0. And then we're at -3, comma, +0.5. So we'll call that 1. So that would be, about right there. And then what else do we got? 0, comma, 1. And then the last one, we'll just throw it out there, is 5, comma, 3/2. So if that's 2, we're in the middle. So something like that. And now we're going to start with where we started, and we're going to connect them. And including the orientation means to do this. It wants you to draw arrows. There's no set amount, how many, just enough that we can show the direction. That is called the orientation of the parametric graph. Shows you where it started and where it took off and went to. So if you ever had to graph one of these by hand, that's how you would go about doing it. Do we have any questions there?
Could you go back to the definition?
Yeah. Parametric equations are when x and y are split into two variable or split into two equations, and both of them become dependent on the other variable, which is t. Okay, we'll have you guys try one, and then we'll put the result up. Taylor, fails vertical line test. Are there different parameters for a parametric function? Yeah, so when you have two different, so they're not technically parametric functions, it's a parametric curve. Function would be the wrong word to be using for the exact reason that you just said. So parametric curve would be the correct language. All right, let's have you guys map one of these out just because that seems like a reasonable thing to do. So I will stay quiet for a couple minutes and then I will put my work up when you guys are ready. So go ahead and get to work and we'll talk in about 2-3 minutes. All right, Ray, and I just saw your question, so I'll answer it for you right now. So here's what I came up with. Taylor, that was the same question Rayanne had. So when you're plugging in for y, all we can do is just plug in the numbers you got. So if you plug in 0, you get 0, 1, you get 1, 2, you get 2, 3, you get 3, and so on. So when you plug into the x function, that's going to be where you're using your unit circle knowledge. And if it's just equal to y, then that's just going to be the numbers that you're plugging in to begin with. And then when you go to graph this, you should get something that kind of spirals and looks like that. Yeah, y of t equals t does seem like that would make more sense. I'll have to check to see where this problem came from. I don't disagree with your logic there, Ian. Okay, anyways, that's the gist here on graphing one of these. The more important thing that we're going to be looking at with these will be taking derivatives of them. So our format for taking a derivative is right here. So this is going to be the derivative of a parametric equation. The formula for the derivative of a parametric equation, simply put, is take the derivative of the y1 with respect to t and divide it by the derivative of x with respect to t. So your derivative is going to be dy dt over dx dt. Okay. And then what do we know about horizontal and vertical tangents from earlier in the year? If you want a horizontal tangent, you set the top of the derivative equal to 0. If you want a vertical tangent, we set the bottom of the derivative equal to 0. And the same rules would apply to parametric equations. So if we want a horizontal tangent line, we would be setting this top piece dy dt to 0. And vice versa, a vertical tangent line, we would be setting the bottom of that equal to 0. Okay, let's see what we've got here for a problem. So it says, find the line tangent to the parametric curve when t equals 1 for x of t is equal to 3t squared and y of t is equal to 2t. Okay, so what do we need whenever we're going to do a tangent line? We're finding a tangent line. So the way I've always taught it is we're going to make a box. And in our box, we're going to need a point and we're going to need our tangent slope. All right, but now when it comes time for the point, we're dealing with parametrics. So we should go off to the side. And that's kind of why I showed you guys how to graph first so that you could get comfortable making a table. So if we make the same kind of table, the XYT table, and all we know though now is we're just going to be plugging in 1. So if I plug in 1 for my t value, what's that going to result in? The x would be 3 and the y would be 2. So now that tells me my point is going to be 3, 2. And then the next thing we need to find the derivative. To take the derivative of a parametric, we want to go up here to the top and we're going to use this formula dy dt dx dt. So that tells me that the derivative of this is going to be equal to the derivative of the y term over the derivative of the x term. And then what do we do with derivatives? We plug in the value. But here's where we got to be careful, guys. What variable do we got here? This is a t. This is x and y. The t value in this problem is 1. So this is going to give us 2 over 6, which is 1/3. So our slope is 1 over 3. And then just like in all of our other tangent line problems, once you've completed the box, we're good to go. So this would be y minus 2 is equal to 1/3 x minus 3. Any questions there? Okay, let's have you guys try one then on your own. So we are going to find the line tangent to the parametric curve. And then we got our equations listed below. So I'll stay quiet. You guys get to work, see what you come up with. All right, so if we're doing a tangent line, we should make a box, and our box is going to have a point and a slope. And then whenever I'm doing parametrics, that's just how I do it. I like to go up to the side, make a T, X, Y table, and just map out what we've got. So I see that for T is equal to 2, that's going to give us 16 for our X, 10 for our Y. So that is 16, comma, 10. And then we want to take the derivative. So it's going to be the derivative of my Y term. Dy dx is equal to the derivative of my Y term over the derivative of my X term. So that should be 6t squared. And into this, we're going to be plugging in the t value. And the t value in this case is 2. So that would be 5 over, what's that give us? 24. And we'll call that our slope. Okay. And then once you've completed the box, y minus 10 is equal to 5 over 24, x minus 16. Any questions on those? All right. Next, we've got, let's see. Let's go ahead and have you guys try this one. So we're finding the line tangent at t equals pi. Now, careful on this one because this looks like it's a little more to that angle. So see what you come up with. Okay, so same kind of thing. We should make a box. And our box is going to have the points. And I need a slope underneath it. So we're going to go off to the side, make a table. And that's going to be T, X, Y. And the T value is pi. So if we plug pi in, sine of 2 pi is 0. And if we plug pi in over here, cosine of pi, that should give us -1. So that's the point, 0, -1. And then for our derivative, dy dx, we're going to take the derivative of the y term. So cosine goes to negative sine t over. All right, the derivative of the x terms. Now we have some chain rule here. To do a trig derivative, it's trig prime. So it's going to be 2 cosine. Keep the stuff, derive the stuff. And when I derive the stuff, it gives us an extra 2 that's going to come out front and turn that to a 4. So before we plug into this, does anybody have any questions on this? This bottom piece is us taking the derivative of this, but it's through using the trig chain rule. So it's 2 cosine, keep the stuff, derive the stuff. The derivative of this is 2, which makes that out front a 4. And then into that, we're going to plug in pi for t. And that's not going to be too bad because sine of pi is 0. And that means this is going to be 0, assuming we get something down here. Cosine of 0 is 1. So times 4 is 4. But either way, that's going to give us 0. So y plus 1 is equal to 0, x minus 0. I would go ahead and solve that and say y equals -1. All right, this one has a part B to it. So the next part says, find all the vertical and horizontal tangent points. Find all the vertical and horizontal points of tangency, excuse me, it means the same thing, on the interval 0 to 2 pi. So remember how we said a second ago how we were going to do that. So back to our original definition, it's a horizontal tangent if you set the top of the derivative to 0. It's a vertical tangent if you set the bottom of that derivative to 0. And we have the derivative right here. All right, so locate any vertical and horizontal tangents for me, and we'll talk in a couple minutes. Sorry, I was on mute. Okay, so Here is what I had come up with off to the side. For horizontal tangents, we set the top to 0. That is sine t equals to 0. Where is that true? That would be 0 pi 2 pi. If you solve the other one for 0, that's basically saying where's cosine equal to 0? That's pi over 2, 3 pi over 2. And then solving that angle out gives you final answers of pi over 4 and 3 pi over 4. Any questions on that? In general, parametrics, for the most part, at the beginning of this is pretty straightforward. You got to remember what you're doing, just take your time, but not a big deal. So we'll wrap up tonight here with one more problem. It's a pretty big mess. This will take us a little bit to get through. And then we'll keep going on this. We're going to spend 3 or so class periods doing parametrics, maybe even 4 periods. There's a lot of just little problems like this that pop up. So for this one, we've got the curve represented by the parametric equation x of t is this and y of t is this, crosses over itself at 0, 4, as shown below, and thus has 2 tangent lines. So we could get one tangent line going that way, one tangent line going that way. Find the equation for each tangent line. Okay, so the thing that is missing in this question that all the other problems that we have looked at so far is there's no t value being given here. If you peek back at all the other tangent lines we just did, you had x of t is this equation, y of t is this equation, and then it said, oh, and also t is equal to blank. So what we're missing here is the t is equal to blank in order to get going, because if it told us right away and t is equal to 3 or whatever, we would just get going, right? We would make an XYT table, plug in that, take a derivative, and do the same thing. So if you don't have t given to you, we got to look up here and say, well, what do we know? We know the x equation is going to be equal to 0, and the y equation is going to be equal to 4, just based off of this point. So we're going to take x of t, which is t to the third minus 4t, and I'm going to set it equal to 0. And I'm going to set the y equation, t squared, we're going to set it equal to 4. And we're going to go through and solve. And remember that x and y are both going to be within relationship to t. So when we solve this, this is the x side. I'll put a little x above this. And this is the y side. What happens when we solve? So we GCF this, we take out a t, and that leaves us with t squared minus 4. So that's going to be t. And then if we factor that into t plus 2, t minus 2, on the x side, we are coming up with 0, -2, and 2. When we solve the y side, you can do this however you want. If you want to take the square root of both sides, you can, but just keep in mind that if you do that method, you got to do plus or minus the square root. So that should be giving you plus or minus 2. I prefer to just take everything to the same side and factor. That's the algebra 2 teacher, and I like everything on the same side. Either or gives you plus or minus 2. So, and so here's the deal. We are looking for where these things share something in relationship to t. So since they match at -2 and 2, keep in mind, we said there were how many tangent lines to this question? 2. We're looking for where these things line up with t. So this value, we're going to cross that out. That is considered extraneous because they don't line up. But when your parametrics both have a similar t term, they share that, we can go ahead and say now for this problem that this is going to be at t equals 2 and t equals -2. Okay, so now read this question from scratch. I'm now telling you, here's the x curve, here's the y curve. And I'm also telling you that t is going to be equal to 2 and also -2. And we want 2 totally separate tangent lines. So it's like doing the previous problems twice now. Once for t is 2, once for t is -2, and you should be able to, based on our previous conversation, go through and figure that out. So I will stay quiet for about 2-3 minutes, see if you can pick up from there and finish this problem out. So I came up with, here's my t-table. So just make two different sets. When we're doing the one for 2, there's your information. Here's your first line. When we're doing the one for -2, there's your information. There's our other line. Our derivative is right here. And then you just plug into each to get your information, and you've got them both. Does that make sense, guys? Do we have any questions? Anything? Pretty easy. Okay. So this will keep building. We do second derivatives, we do concavity, we do some stuff called arc length. That gets a little messy with the calculus. That's a lot of calculations. Other than that, that's kind of going to be it for the first half of parametrics. So on Thursday, we will wrap up this with another 30-40 minutes with the topics I just described. And we will keep going from there. So if you don't have any questions, enjoy your night. And I will see you guys in class tomorrow for AB, where we will be starting differential equations. So see you guys tomorrow.
Thank you.